Okay, welcome everyone in our newest addition to our live webinar tutorial series. Today we are going to talk a little bit about storage system in FlexSim. Is one thing that a lot of you ask about after our previous webinar. So here you go. We will do some warehousing, some storage system logic, some storage slot labels and everything. Okay. And today, as I said before, I would like to show you some basics about storage system and warehousing in FlexSim. If you have any question during our presentation, try to write them in the chat, okay? And if I will think that this is a good question for this moment, I will answer it. If not, maybe I will try to answer it at the end of a given section or at the end of the whole webinar. Okay. Okay, so I think we can start now. So maybe new model. Okay, so let's talk about warehousing FlexSim a little bit. So from version 19.1 or 0.2, there is new addition to FlexSim new tool, and it's called warehousing. And warehousing consists, of course, consists in numerous objects like racks, gravity flow racks, push back racks, drive-in racks, floor storage, but most important is this tool called storage system. This tool lets you build even very big warehouse in a relatively easy way, comparing to how it was before and how it works. Let's build some basic model, okay? So let's say we have some rack. Let's say we have some source, some queue, and some transport. And we want to build some model when our forklift is going to transport our products onto the rack. Basic is relatively easy. I would say same as was before, but if you remember the previous version of the racks, a lot of things change with these racks. So when you click on the rack, on the right side, you have all the options about it, starting with edit dimension. Here you can specify how big is your rack, what is the size, width, height of the level, bay, etc. How many slots per bay. So you can specify it here. You can also mark slots that aren't storage slot. So where you don't want to store anything, like for example, some corridor in a rack. Of course, you can also resize it using the red or green arrows. So those things doesn't change as much. What was changed is the logic. So first of all, you have something called slot. So slot is like the one unit, one cell in the rack. So right now, for example, we have 2 slots per bay. So in this area, we will have 2 slots. And these slots, the slot logic, let us create a slot assignment logic into our racks. How it works. And basically, each slot can have labels. So we can create in storage system slot label. Let's call it, for example, product. And after I create this label, I can set value of this label onto every slot using this paint slot labels tool. So for example, I would like to paint this with the product. You can choose the label here. And I would say product 1 will go, for example, here. Product 2 will go here. And product 3 will go here. Yeah? So I have set some values. So this cell has a label called product, and the value of this label is 1, here is 2, and here is 3. So if I have it, I can now change the slot assignment strategy logic. Before, it was first slot with space. Space means that there is enough space so I can fit the product onto a given slot. If I change it, for example, for matching labels, then it will try to find me the slots with the matching labels. For example, right now, let's us to create some on the source, create some label and color. Let's call it also product with the value 1, 3. So right now we have 3 different colors, but I want to store them in a given slot. So right now I can change the slot assignment strategy, not for the first slot with space, but for example, to matching labels. So I'm going to match label product because that's how I've named this label. You can see it in storage system, this product. I'm going to match it with the labels on the item that's also called product. In this case, if I reset and run it, see that the forklift will distribute the product onto the racks according to my paint slot, according to the labels I've painted onto this rack. Yeah, so you can see it fit only as many as it can, and then it stops. It stopped because I don't have more slots with the corresponding labels. So I don't have, if I go again, the paint slot labels, I only have 1 slot that is red, 1 slot that is green, and 1 slot that's blue. And I also have this checkbox here marked that this slot must have space. If I uncheck it, then it will fill out the product. Yeah. So I will leave this marked for now on. Okay. So I create the logic so I can put the product where I want. So I can, for example, again, go back to my tool with the paint slot labels, choose product 3, and for example, I want to paint whole bay. So this will be the bay for example 3, this will be the bay for 2, and this will be the bay for 1. So if I now reset and run it, he will store the product into each bay according to how I painted this here. So as you can see, the bases are rather simple. Yeah? You just paint the racks and etc. however you want, and then you can create the logic so the product can be stored in a given location. The same logic applies to floor storage. So you have floor storage here, for example, and let me just redirect this connection. You can also set the logic here, matching labels. Again, I'm going to match label product on the slot with the label product onto the item. And I will also go to paint slot labels, choose my label product, and maybe this will be for 1, this will be for 2, and this will be for 3. So if I reset and run it, it will be stored according to this logic. Yeah? The space on floor storage can be increased by just increasing its height. Yeah? So this way you can increase how big, how many products you can store on a one cell. So how high is going to be your tower. So I would say this is the basics. So the basic is that on the racks, on each slot of the rack, there are labels, and this label can have values. And thanks to these values on these slots, we can specify where I can put which product. Okay? This is like the basics. It gets a little more complicated when you want to do this in process flow or when you want to build a little more complicated warehouse. Yeah? So let us try to do this now. Okay, so we have the source. Let's say we have the queue. And let's say we'll have 4 racks. 1, 2, 3, and 4. And we have four racks right now. Okay. We'll have some products. I would say we will have, let's say, 4 different products. So let's leave type. We have 4 products. And we're going to have forklift that we want, that this forklift needs to transport this onto each rack. Okay. But what is our logic here? In this case, it's going to be like, we'll create some label. Let's call it product again. Okay. And with small p, product. And we'll paint this in a bay. And let's say this is for product 1. This is 2. This is 3. This is 4. Yeah. And this is 2, 3, 4. 1, 2, 3, 4. Okay. This is my logic. So you can see there's always one bay that is the closest in the each area. Yeah. So we have 4, 1, 2, 3, 4. 1, 2. And again, we're going to be 1, 2, 3, 4. 1, 2. So a little more sophisticated, I would guess. Yeah. So let's start building the logic. Yeah. And let's say we would like to build this using process flow. So let's open process flow. Let's start our model. We'll have some event trigger source here on entry. Let's name it box, for example. Let's name it box. Let's have some resources. So we'll have our forklift. Our resource, let's have some acquire. And we'll name it here forklift. Okay. So recent run, we are ready here to create our logic. Okay. Maybe we'll check this box, arrival at time 0, so we don't have to wait for the first part to arrive on this queue. So we are starting our logic. Let's start in classical way. So let's have some travel. So our forklift will travel to this queue. Let's have some load process. So let's have our forklift pick up this box. So reset run. We are here. And now we need to find out the good place to store this product. Okay, we know it's type 1. So we know we are looking to, let's say, red slot. Yeah, so if I see, I will look for the red slot, but I want to find the slot as close as possible to this queue. Yeah. So I want to first look here. If there is not enough space here, then here, then here, then here, then here, and so on, and so on. So in process flow, also like this small library called warehousing. And you have 2 blocks here. It's find item and find slot. In this case, we're going to look for a slot. So I want to find the slot. And in this find slot, we can write the query how you would like to look for the slot. And in this case, I would like to look for where product. Yes, so where this label product, yes, equals on token. We're going to use $1 because parameter 1 is our token. Dot box dot type. So when the product is the same as a type on our box. Yes. So this is like the first part of our logic. Yeah. So if I for now leave it like this, we look for the slot, and the slot will be available under token slot. The token label and name slot on the token, and here I need to specify what I want to assign to this slot. And in this case, it's going to be our box. So right now, if I reset and run this logic, pick it up, okay? I have token here, and he find me a slot. So here you can see the address of the slot. So the slot is on the rack number 1, variable bay 1, level 1, slot 1. Yeah. So it's a first bay, first level, first slot on the first rack. So it means it's going to be here. Yeah, it was found. It was found. And now I can use this because this place is already, there's like a reservation on this place already in place. So no other object will take this slot, take this slot for me. If I find the slot, I need to find out the address of the rack, because here I have only the address for the slot, not the address for the rack. So let's, for example, here create assign labels. So here we're going to look for the rack addresses. This is our rack address. So we look for the rack. And in this case, I need to write some logic. So from token slot, and we're going to treat this as the storage slot. And it's going to be storage object. Yeah? This is the logic. It can be, this line, it's all over in manual. So if you click help anywhere where there's warehousing, you will properly find this line. And this line lets you find out the storage object. It means the object that the slot is in. So if I reset and run right now, I will have the label rack, and it's rack number 1. So now if I know the rack, I can write the logic. So I know the rack, so I can travel. So my forklift can now travel to my rack, and it can unload. So right now my forklift can unload my box onto my rack. And I can, for example, if it's finished, I can release my forklift. So if I reset and run, you will see it works. But right now, I only look for the slot that has the product label equals 1, so equals the type. So on each of this token, you can see is the same slot, 1131, because I don't have any more logic written here in this query. So it always finds me the same slot. So if I want to build up a little bit to it, okay, I can click on this arrow and I order slots, or I can filter it a little more. Yeah? So for example, I want to order it by bay ID. Yeah? So the closest, this is the first bay. Yeah? This is the first bay, second bay, third, fourth, and so on and so on. Yes, I want to put it the closest, and I also want to find only the slot that has enough space for my product. And here I need to specify for what I need to check the space. So I need to check the space if my token is $1 box will fit in this slot. If I have this logic and if I hit reset run, now you can see it's spread out, yeah, the product. So if it finished the red here, faster, the fork will fill this rack for me in the way I want it. Okay? So let's assume it works. Yeah? So in the find slot is a block where you can specify the exact logic. How do you want to look for a location of the product in your warehouse? So you can specify, for example, the labels on the slot according to your logic. You can create the logic that looks if it has enough space. You can also create, for example, that you don't want, if you have here slot content, it means how many items are already on the slot. For example, let's say you are building a rack that is double deep. So in each slot, you don't want to have more than 2 items, or more than 2 totes, or more than 2 pallets, depending on what you are building. Yeah? or maybe empty slot. So you want to look for the slot that's totally empty. Okay? Same with the orders. And you can also order random slot. If you don't know the logic and just want to make a model of something and don't have the logic, you can always choose random slot. So if you choose a slot randomly from all the slot you have in the warehouse. Okay? So this is the logic. So this is like the base. Yeah. And what's also important, when you do look for the slot, it looks through every slot on every racks. What I mean, let's say that, for example, you have closely the same logic here. So you have the same logic, but it's a different warehouse in different parts of your model. Yeah. And this warehouse, it only has 2 racks. If I copy the racks, I will copy the racks with the slot labels. So you can see it's the same. So let's say I have maybe some different process that is happening down there. Yeah. I will copy this logic, just change the transporter and change the queue. Name it the same, box, assign, travel here. Okay, so I have 2 logic, and I want for this forklift to only look for a place in this warehouse, and for this forklift only to look at the place in this warehouse. Because right now, if I leave it like I have, yeah, they will look in the both warehouse. And so if I want to do it, I can, for example, create again some storage logic. Let's name it, for example, warehouse number. And I will just, again, paint my labels. I will paint my label warehouse number, all slots in the same object. And this is going to be my warehouse number 1. And this is going to be my warehouse number 2. Okay. So we have, and we can specify now, okay, where product is the same as box. In this case, where warehouse number equals 1. And here we specify where warehouse number equals 2. If you reset and run it, you see that each forklift only looks for location in their warehouse. So this one only works in this location, and this one only works in this location. Yeah. I guess someone asked a question, but let us do the unloading. Yeah, so we know how to load something onto the rack. Now we want to unload something onto the rack from the racks. Yeah, so let's build up to it. Okay, so let's say we have some queue on the other side, and let's say another forklift that will pick up product from this warehouse. So let's build it. Let's say, for example, I would like to pick up product, the source, every, I would say, 2 minutes, just for the example, okay? So we have token every 2 minutes. We need to have some resource, some acquire. Our resource is going to be our forklift. And acquire, let's also name it forklift. So every 2 minutes, I want to look for some product in my warehouse. And for it, I will have block find item. So I'm going to look for something. This block is very similar to find slot, but it doesn't return me the slot. It returns me the item. It returns me the object on the racks that I want to take. Yeah? For example, let's say I will make some logic like which product, yeah, and let's say it's going to be product, and let's be like random distribution, so uniform 1, 4, because I have 4 types of product there. I'm going to find for item, so I will look for item where match item label. So I'm looking for label on the items, not on the slots. Yeah? So I'm looking for item with the label called product. Is it product? Yeah, no, it's type. Where my type label on each flow item equals my product label that is set here. Yeah. If I have it, let's assign to token box again. So now I need to travel to something. So my forklift needs to go where this product is. So I can just use the box.up. Then load this. So my forklift take my box, then it travels again. So my forklift go to this queue, and then it unloads. So my forklift take the box and put it right back in this queue and release. I mean, this task is finished. And you can see it looks in both warehouses. Why? Because I didn't specify something different. Yeah. So for example, if I want this to look in a certain warehouse, I can also add parameter where slot labels. Yeah. So its label name is going to be warehouse number. If I remember correctly, it's warehouse number. Yeah. Equals, for example, 1. So look only in the first warehouse. Reasonable. Yeah. So now it only looks here. Okay, I see maybe some follow-up. Okay, you want to split this into several queues. Yeah. So maybe I will elaborate a little more even onto it. So let's say, for example, you have some global table. Have some global table. Let's name it orders. Yeah. Let it be like 3 column, 2 column, let's say 3 rows, for example. And this is like the product. And this is the queue number. Yeah? So I need to put at 1, 2, 3, and I want to put on the product queue 1, 1, 2, for example. Okay. So I will not have 1 queue. I will have like queue number 1 here and queue number 2 here. But I want to specify it in the global table. Okay. Okay, so maybe I won't have something like this. Okay. Maybe I will have some source, shadow source. I will create quantity, the number of token, the same as number of rows in this table. I will enumerate, let's name it row orders. And I will put here token index. And this will create 3 tokens for me and enumerate them. So I have row order 1, row order 2, and row order 3. So right now, which product? It's not going to be uniform, but I'm going to use some global table, our table orders, with the row orders and column 1, because this is the information here. And I will already create the extra logic here, because I want also specify the queue. Okay, so it's going to be queue. Again, by global table lookup from orders, from row orders, and from second column. So right now I will have those two. Yeah, product 1, Q1. So I want to look for item if token product is the same, because now the product is the value from my global table. Okay, and look how it was. It was more like pull from list logic. Yeah, so that the token here waits, stays, and waits for the product to be there. So product came, so the token goes. Sometimes it's even a little better when you want to acquire the product, the forklift, only when you are sure that it has something to take. Because if you acquire before find item, then the forklift cannot do any other task because it waits for the item to appear in the warehouse. But if I find this item before the acquire, then I'm sure that if I'm acquiring the forklift, I know that it will have some work to do. So the item will be already in the warehouse. Yeah. So now you can see I have 3 tokens here, for example. And it is there, it waits. And I have 3. Okay, so I know how to pick up from here. Yeah? So if I know how to pick up, then I need to specify the queues. If I want to specify the queues, I can change its unload. Yeah? So if this travel, okay, I can specify the queue. I have queue number 1, number 2. Now I have multiple ways here. Yeah? I can create assign labels here, for example. Yeah? And I can specify the queue out, let's say, and this queue out will have some value based on this number. Yeah, so I will have some value by case, and this case is going to be token queue, and 1 is here, and 2 is here. Yeah, so this is my logic here, and I will travel to label queue out, and here label queue out. So of course I have multiple ways of how I can model this logic here. Okay, so I can get this information and have products and have queues put right there. Okay, next question I see it's about the initial stock. Yeah, so you want to create some initial stock, and it can be set from the table. It can be set just randomly. It depends on your needs. So, for example, of course, there are multiple ways to do it. Yeah. So, for example, you can write something. Okay, let's say write some source here. Let's say my initial stock would be 100 box. Yeah. So I have 100 tokens. So I will create here some boxes. Yeah. Boxes with the type label same is there. So we put statistical uniform, let's say 1-4, or from a table if you want to have the exact stock, exact initial stock. So you are creating the object here. Then you need to find the slot. Let's say I will just copy it here. So I'm looking for the slot according to this logic. And if I found the slot, I need to have some rack addresses also. And then I can just move this object. So it's going to be item onto this rack and sync and the end. Yeah. So if I now recent run, no, invite score. Yeah. We have product. My product is here. It's type. So I can't put box type here. I need to put item here. And I also need to put item here. If I reset run it, box goes through find slot again here, okay? Where product dot assign to. That's how you end up when you're just copying something without thinking. It's like so. Yeah, I've changed the logic. Yeah, so it created 100 here. If I change the number of warehouse for 2, yes, I created the 100 in a second warehouse here. So if I want to have 1, so now I will create the 100 in this warehouse. If I also want to color it, I can put change visual here. And I can change the visual, so set color by case, item type, item, good. Reset run. And now it's also colored. Okay, best question about how can you find where label is? I think the easiest way is also go to pane slot labels. Yeah? So if you change label here and click on the model, it will automatically repaint. So you can see what is where. So even if I run the simulation, you can see its logic. If you would like choose again, you don't have to paint it to see it. You just can go to this tool. So click on it, left mouse click, choose the label you want to see, and then it will repaint everything so you can see this label. Even if you change label on the go, then if you go again, change it, then you will see the changes in the labels using this tool. So this is the easiest way. Of course, there are some logic, some function that lets you query after all the labels, so you can have the list. But then sometimes it's hard to count, yeah, especially when you have like very high or very long rec. It can be hard for you to see which it is, yeah. Maybe a little more about this these racks, okay, and these 2 blocks. In a find slot, you have the logic use max wait timer. So it means if you don't have this slot, the token will stay here. Yeah, so if I reset and run it, maybe I will save it. Because you never know what will happen. If I reset and run, and maybe I get the full speed. Maybe this should be fill out a little faster. Yeah? It's a lot of tasks here, okay? Here you can see. If I don't have enough space, the token will wait at this find slot activity. Yeah? And because it waits for the slot. Yeah? So you wait for the slot, you can check this box here, max wait timer, and you can specify. So for example, you can specify some extra label or some other logic, of course, to the token, or you can, for example, release token on the second destination, and then with the find slot, write some alternative query here. Yeah, so if you didn't find logic like this, look for logic like this. Or you can also add query here. Yeah? So you can have more queries. Yeah, so you can multiple query here, or you can create the second block. I prefer to do the second block because then it's more easy to me to see how it works. Yeah, because I can easily pull out the stats for this find slot, so I can see how many boxes or how many pallets didn't find the right slot with the, I would say, priority logic, and make some analysis or statistics. Okay, we have another question, Piotr. Will the pre-created boxes also be unloaded and yes, yes. The pre-created, if I recent run it, the start the model, yeah. So you have only the initial stock, and on the initial stock, the forklift will start and go maybe a little too fast. Okay. So I have only some, yeah, the forklift already going here to pick up, and this is the only initial stock that is here. Yeah, so they are taken into consideration here also. Okay, maybe to more to it. Okay, we have this small warehouse, but as you can see, the forklift is coming through the racks. Yeah, so I can maybe make some A star, add some A star to it, some A star navigator. Okay, connect everything to this A star. Connect everything to this A star. So now we see it like this. Yeah, so they won't, I would say, go through the racks anymore. Look at this first, the first pick. Let's say put this one here, so you can see it better. Yeah. So it picks up and it goes back here. You can also create with the A star. If you don't want our forklift like travel just beneath the racks, you can add preferred path. Yeah, so for example, I would say like this. So let's say it's the right side movement. Like this. And now we can copy it. And put in the rack arrays. So now the forklift will travel along this preferred path. Now it looks better. It's very fast, very easy, and I recommend this way of doing things. Okay, so we know some basics. We can create here some alternative. So max by timer, yeah, and the same is here. What's also important for you to know, with the find item here, there's this checkbox here, mark item as outbound. This means that if I find this item and if I mark it as outbound, this means that other logic cannot find this item. So for example, if I have two tokens, look, for example, I would put here 3 of the same product in our data. Yeah. If I reset and run it, 3 tokens will get here in the same time. And each token, yeah, will have different box. This is box 1, yeah. This is the second box, and this is the third box. Yeah? So even if those will get here at the same time, because this checkbox is checked, they are set as outbound. This means that it's, I would say, reserved. Yeah. So no other process can see that this box is still there. Maybe they can see that it's still there, but they can't take it. They can't make the reservation for this box. And it's rather important when you, for example, don't have like here the boxes into the warehouse, but for example, when you have the pallet with the boxes in the warehouse, and you want to just take the pallet. Yeah. So maybe I just build some quick example for you to see what I mean. Yeah. So let's say I have this source, I have this rack, and maybe I will just quickly to some palette. So very quickly, some palette. I could have some palette. Some combiner, fastest way. 12. Yeah. I have palette. Maybe just one palette. And here also 0. And with 0 also here. So right now I have only one palette here. Yeah, one palette with the boxes. And let's say I want to have operator. Let's say this guy here. And I want to operator to pick only one box from my palette. And let's say that this palette will have some label on it. And let's say, let it be 10, for example. So it'll be different from the all other type 10, okay? And I want this guy to go find palette number 10, yeah, and pick up one product from this palette. So if I want to do like this, like let's say quantity with the I will time 0 little later, so I will make sure that the palette is there when I start this logic. I have some resource and acquire, same as before. Operator, yeah. So I have this logic with run. There. I want to go find this palette and pick only one box from this palette. So it's like, I know, picking operation. We want to only take one box from whole palette. We don't want to bring a whole palette from it, yeah? So if I build like this, so I need to look for an item. It only will look for the palette, not the product on the palette. So here I will have where item label, where type. I will just hard code it, let's say 10, where type is 10. So if I reset and run, it already find me. It will find me this palette, yeah, but type capital T. Reset run. Yeah, so it finds this item. So right now I can travel to this item. So my resource will travel to my item. And I can, for example, load. So my resource will load from my item that last means the last box on this palette. So if you reset and run it, you will pick only one box. Yeah. So if I have Q here and make him go all the way here, so I will have my resource go there. And let's have our operator. Again, resource, get our box and put it back here so I can release him. Okay. If I listen one, the first one works. Oh, not the box, but item. Reset run. Yeah. Look, I provide item here, so it moves whole palette. You have to be careful, yeah, because I didn't pick the item here. I picked the item last. And if I unload this, I need to unload this as a resource dot, for example, first, last. He has only one box, so it doesn't really matter. But right now, I don't want to move whole palette, just this box. And why this checkbox is important? For example, if I want to do this twice, if I reset run, the first word, and the second cannot find this palette. I cannot find it because I've marked this palette as an outbound. Yeah. So I need to uncheck it. If I uncheck it, then the first guy will take first, second, because they can see this palette is still on the warehouse. So if I make it outbound, this means that if I find this, mark it as outbound, then it's like I have reservation there and no other process can find it. But if I uncheck it, then I can see this palette, so I can pick up more boxes from this palette. Of course, for example, when I will pick up the last box here, so if I pick up the last box, or if the palette will be empty, then I will mark it as outbound because I don't want other operators to go there and try to pick up the product. Let's maybe take a little look at this load. I write it last. Why last, not first? Because when he picks up, when I write last there, it means I'm going to pick up a LIFO from the palette, I would say. So the last product was put on the palette. So I would say it was from the top of the palette. If I put it first, if I reset and run it, you pick the product first came in the palette, and it doesn't look very good. Yeah? Maybe even if they're the same product, the same type, so it doesn't matter which one you pick. It just looks better to pick the last one, so you don't have like this floating product onto the palette. Yeah? Yeah, so this is important. I want to elaborate on this a little bit more because this is important when you try to build a warehouse with the picking operation from palette, from totes, from Euro boxes, etc. Yeah? Here also you have this max by timer, same as before. It means the same as before that if I couldn't find the item here, for example, maybe look for it in the other warehouse, or maybe just abandon it, or maybe recheck after 1 hour and in the meantime do something differently. Yeah? It hugely depends on how you like to build this. Okay? Few more important things. Storage system. Here is the slot labels. I think it's rather self-explanatory. The product can, of course, choose the color palette. It means which color, which value of this label has which color. It's purely aesthetical, I would say. Visualization, this means how would you like for your rack to look like. You can make a little good customization of your racks if you want, like which texture, colors, almost everything. If you want your rack to look exactly like in the real system, this is the visualization tab. You can also just click on this rack and just choose the already built visualization. So you click on it, you have this visualization list, and you can, for example, create some so without the floor on the cell, only pallet rack, only, for example, some gravity flow rollers, a lot of different ways. Sometimes, for example, it's good just to have the wireframe. I open it so I can see that, okay, there is the rack there, but it doesn't obstruct my view. Yeah. So I can just see where everything is. It's especially useful when you have like bigger warehouse, I know, 200, 300, 400 racks, and you want to see what's in there. Yeah? It will be very hard if you have all these racks here. In the wireframe, you can exactly see what is where. So I would say its opacity is very good. Item. Item is, for example, you want to automatically restack items. Restacking means, for example, if I have like here, and if I have this checked, if I get this box, it will automatically restack. Yeah, so it's also a visualization thing. It can be switched off if you want to increase the performance of the model. You also have the virtualize items. This is a very important feature. In the virtualize, if you want to virtualize items, it means that basically, like to simplify it, and the FlexSim will destroy the object that go into the racks and create only visualization of this item. It's very important. For example, you have the very big warehouse, like for example, I know 100,000 pallets. Yeah? Then you like to make this virtualized items. So you don't have in the model 100,000 objects. Yeah? So the rug like only stores some information about this palette. And of course, you can see in the model, but you cannot click it, it's just a virtualization. And you need to specify which label on this item that will become virtualized can be accessed. Yeah, so for example, if you have like only ID on the palette and you want to use this ID in some query, you have to put this here. Yeah, so you have to put this ID here. So when you use the logic find item, they can see this label. It's important, especially in the bigger model, and it greatly enhances the performance of the model if you have very big warehouses or multiple objects in the warehouse. Next up, address schemes. Also very important. If you have like a WMS system, and your WMS system has some fixed information about the localization, you can use the find slot to find the slot, but you can also use assign labels, have warehousing, to get a storage slot by its address. And address means this code. So for example, let's say you have FlexSim 2 and 2 without maybe this. So this is how your warehouse uses the slots. Yeah, so it's like first rack, first IL ID, bay level slot. So for example, maybe it can be 30 like this. Yeah, it hugely depends on how do you use it, or what is the location key in your WMS. If you create this correctly, yeah, this addressing schematics, yeah, in the default schemes, of course you can have multiple schemes. Then, for example, you can use this logic, get address, so you can get exact slot the same way as your WMS uses it. So for example, if I would write like 01 here, here 01, 001, 01, it will know that I mean, for example, this slot. Yeah? And it's very helpful when you're building the model using historical data from WMS, and in the historical data WMS you have this information. So you have like the address, the key for the slot location, and thanks to this key, you can create this logic, and then on the racks you can specify that he uses this schematics. Let's say my scheme, yeah, okay, for example. So you can then go to rack and choose, okay, it uses my schematic, my schemes, and this starts from bay 1, for example, yeah, and it's progressing for X plus, and this will start, for example, from bay, I don't know, 25 or something like this, yeah. So you can then create the exact, I would say, exact representation of the warehouse that corresponds with your WMS data. And it's very good when you have like historical data, where was put, what was put where, using this location key, and then you can very easily rebuild this model. So you have like the current state model with all the movement without a lot of logic. Just have from the orders, for example, you have product, and then you have another column, and this column, of course, it has to be strings. It's going to be like location. And here's going to be this location is like 01, 01, 01, yeah? So then you can interpret other information like this. So the same as your WMS uses, and it, of course, is a huge improvement on how you can build model using historical data. We want to find the slot address just by the name of location, not by the logic itself. So you just know where you should put there. Okay. 1 hour has passed. As I said, this is just the basics of the warehouse. Of course, there's a lot more to it, especially when you try to build a warehouse or the small logic, especially here with the finding slots. You have some groups, some areas. Sometimes, for example, you have information about the temperature in the food warehouses. Yeah. So for example, you have different warehouses with different temperature. Yeah. You can just, for example, create extra label, name it temperature. Yeah. I think that's the correct spelling. And you can say, okay, for example, this warehouse, in this warehouse, the temperature is just temperature, yeah, -8, yeah, and in this is -20, for example, yeah. So you can create very good, very sophisticated logic in a rather simple way using this find slot, find items blocks. You can create even sophisticated logic on WMS in your model in a rather quick way. So thank you very much for today. If you want, just write us some email about what would you like to see next. Okay, maybe there are some questions. Maybe you can just write them. I will try to quickly answer it. Okay, but thank you very much for your time, and I will hope see you next month with some new topic. What will it be? Depends solely upon you. And of course, the recording will be available to you on our YouTube channel, so you can go back to it, see it yourself, and maybe try out building your own warehouse. Okay, thank you very much again. Stay safe, stay healthy in these times, and I hope see you soon.